Hello and welcome to Shaurav's classes. Here in this video I am going to cover a very significant and very important part of statistics, which is statistical inference, theory of estimation. Now, what do we mean by statistical inference? By statistical inference we mean drawing conclusion or making decision about population based on information collected from sample. So obviously, as we do not know the population or it is not possible to cover the entire population all the time, so we make a smaller section, we take a smaller section from the population which is termed as sample, and from the information that we collect from this sample, we want to make certain decision or inference about the population. So how we do this? This entire process is known as the statistical inference and theory of estimation. So first what we do, we take information from sample, and then on the basis of that we make decision regarding population. So this is the very simple thing. Okay, so the statistical inference it has two parts. One is estimation and the other part is testing of hypothesis. These two are very important part of statistical inference, one of the core parts of statistics. So in estimation we have two kind of estimation: point estimation and interval estimation. So we have covered the meaning of statistical inference. So what do we mean about statistical inference? Then the major part, that is the estimation and testing of hypothesis. There are two kind of estimation, that is the point estimation and interval estimation. Next we want to see what do we mean by So what do we mean by estimation? So it is nothing but, so it discusses the ways of assigning values to a population parameters. So these population parameters can be mean or can be variance. So as we don't know the population entirely, so we know the sample, so we want to collect information about the sample and we are making inference about the population. So that is the job of this chapter. So we are basically, it discusses the ways of assigning values to population parameters. So I can keep the entire part in bracket. So the population parameter, I mean mean and variance. So there can be other things, but for example mean and variance. So two population parameters based on values of corresponding statistics. So it can be a values, it can be value, or it can be a function of sample observations. So by estimation, what do we mean? We mean it discusses the ways of assigning values to a population parameter. The population parameter can be mean and variance based on values corresponding of corresponding statistics, and this can be a function of sample observations. Now the statistics used to estimate a population parameter is called estimator. So this is very important. The statistics used to estimate the population parameter is called the estimator, and the value of the estimator is called estimate. So the first part is what do we mean by statistical inference. The second is what are the two parts of statistical inference, the testing of hypothesis and the estimation. Then what do we mean by estimation? There can be point estimation, there can be interval estimation. Then what is the meaning of estimator and what is the meaning of estimate? This part we have covered. The next part is what is point estimator? So what is point estimator? So point estimator is actually a single quantity. It is a single quantity based on sample data used to estimate the parameter. So this is a single quantity based on sample data used to estimate the parameter. So this is point estimator. So what is interval estimator? So interval estimator is an interval, obviously it deals with interval, an interval which is formed by two quantities. An interval which is based on two quantities or which is formed by two quantities based on sample data within which the parameter will lie with very high probability. So it basically provides an interval by two quantities based on the sample data within which the parameters will lie with very high probability. So the chances of lying the parameter within that interval is very high. So this is what we mean by interval estimation. So some examples where estimation may be used. One example can be a market research group. Suppose a market research group may be interested in estimating the average gain, may be interested in estimating the average hours the students spends in watching television per week. Or average cost of repairing a car. So a person may wish to have an estimate regarding that. Next, some of the basic features or properties of a good estimator. This is absolutely important. So one is unbiasedness. Which is very important, utmost important. One of the very important properties, unbiasedness. Second is consistency. Third is efficiency. And fourth is sufficiency. So, the very important property of the estimators are unbiasedness, consistency, efficiency and sufficiency. So, what do we mean by unbiasedness? It is the most desirable properties of an estimator. Most desirable property. So the sampling distribution of a point estimator should be centered over the true value of the parameter to be estimated. So, from the picture, as we can see, for the unbiased estimator, the distribution, the mean of the distribution for the unbiased estimator will be closely equal to the true value of the parameter. If this is true, then we call the T is an unbiased estimator. But if the distribution of a estimator such as T prime, if it is the mean of the distribution is way above the true value of the parameter, then also we say it is a biased estimator. So T prime is a biased estimator, whereas T is an unbiased estimator. So for an unbiased estimator, the expected mean of the distribution for the parameter T, for the estimator T will be closely equal to the value of theta, whereas for the biased estimator such as T prime, the mean value of T prime will be either above or below the true value of theta. Then this T is called the unbiased estimator and T prime called the biased estimator. In this case, as we can see, expected value of T prime is greater than theta. So we say that T prime overestimates theta, but if expected value of T prime is actually lower than theta, then we say that T prime underestimates theta. So this is two very important and crucial part. Now then what we conclude? First, an unbiased estimator will be such that, suppose the unbiased estimator is T, it will be such that expected value of T, which is the mean value of T, so the mean value that we get from the distribution must be equals to theta, which is the parameter. Now here to note, one, unbiased estimators are not unique. An unbiased estimator may not exist for a parameter theta. So for example, the sample mean x bar, which is actually 1 by n summation of xi, where I running from 1 to n, is an unbiased estimator of population mean mu. So expectation of x bar is equals to mu. And if expectation of t, which is the estimator and estimated value, if it is greater than theta or less than theta, then the difference between two which is expected value of t minus theta is equals to the bias or the amount of bias. So we can write formally Bt equals to expected value of t minus theta. So in this video I have covered the first property and the basics of estimation. In the next videos I will be covering the other properties of unbiasedness like minimum square error and the minimum variance unbiased estimator and all the blue properties, and then I will carry forward to the concept of efficiency, sufficiency and so on. So until next time, thank you.